Okay, guys, greetings. This is a walkthrough video of the practice test for quarter four. I'm going to be moving pretty quick, so pause if you need to review some things. Okay, first of all, these formulas are going to be given to you. However, formulas that won't be given to you are these, like a sub n equals a sub 1 times r to the power of n minus 1, or for finite arithmetic, a sub n equals the zeroth term plus the difference times n. Those will not be given to you, but you should be able to recognize them and use them. Now, write out and evaluate the sum. Okay, so all this is saying is put in the numbers 1 to 5 into that formula. So if I put a 1 into this, 2 to the first is 2, 2 minus 1 is 1, plus if I put a 2 in there, 2 to the second is 4, 4 minus 1 is 3, plus put a 3 in there, 2 to the power of 3 is 8, 8 minus 1 is 7, 2 to the fourth is 16, minus 1 is 15, and 2 to the fifth is 32, 32 minus 1 is 31, and if I add these all together, 1 plus 3 is 4, plus 7 is 11, plus 15 is 26, plus 31 is 57. Write this using sigma notation. Okay, all that this is saying is to put this into something that looks like this down here, number 4. So I need the sigma, and let's go ahead and start with n equals 1. We always start with 1. And if I got to think here, what's happening? 3, 6, 9. It's multiplying by 3. That means it's a geometric series. So I'm going to use this formula up here. The first term, which is 3 times the ratio, it's multiplying by, oh, wait, what's happening? 3 plus 6 is, that's not arithmetic, that's not geometric. It's just adding 3 every time, isn't it? Yeah, I'm being dumb. So 3 plus 3 is 6, 6 plus 3 is 9. Yeah, this is arithmetic, so I'm going to use this formula. The zeroth term, well, the zeroth term is if I go backwards, that makes a 0 here. So 0 plus 3 times n. And if you're thinking, I really don't need that 0, you're exactly right. And then how is this? 3, I'm just counting my fingers. 3, 6, 9, 12, 15, 18, 21, 24, 27. That's the 9th term. Or yeah, 27 times 3 is 9. That's all that's asking. If you leave the 0 there, great. If you don't, that's fine too. Okay. Term if it's arithmetic or geometric, then evaluate the sum using one of the formulas. Negative 3 plus 9, 27. So I can see this is switching negative, positive, negative. This is a geometric, and it's multiplying by negative 3 every time. Okay, so I'm going to write down geometric, and then I'm going to use the sum using this formula. So the first term, which is negative 3, times 1 minus the ratio, which is negative 3 to the power of n, which I don't know, so I'm going to leave that alone for a second. All over 1 minus the negative 3. Now we got to figure out what n is. So to figure out n, I'm just going to go, okay, I started with negative 3, right? Negative 3 times negative 3. That gave me 9. That was the second term. Okay, times a negative 3. That's the third term. This would be the fourth term, fifth term, sixth term, seventh term, eighth term. There it is, eighth term. So that's the eighth term up here. Okay, now if I type that in my calculator just like it looks, parenthesis negative 3, 1 minus parenthesis negative 3 to the power of 8, and it is important that the parentheses are exactly where they are, all over 1 minus a negative 3, and I go equals 4,920. Okay, 5k minus 14. I recognize that's a geometric because it looks like that. So it's not geometric, arithmetic. And there's my common difference. So the difference is 5. It is arithmetic. And my formula for arithmetic is the n, which is 15, 15 over 2, times the first term. To find the first term, what's 5 times 1 minus 14? Negative 9. Negative 9 plus the 15th term. If I put a 15 in there, 5 times 15 minus 14 gives me 61. Okay, so 15 over 2 times, times -9 plus 61. Off screen, I'm just typing that in my calculator exactly like it looks. I get 390. Okay, 2, 8, 14. This is adding 6 every time. That means it's an arithmetic sequence, and the difference is 6. So I'm going to go the number of terms, which I don't know. So I'll figure that out in a moment. There's the first term, which is 2, plus the last term. Oops, can't see anything. Okay, hold on. I got you. Okay, so arithmetic is it's adding 6 every time. Difference is 6. I don't know the number of terms, but the first term is 2, the last term is 116. And I need to figure out how many terms there are. Now, I could go 2 plus 8 was 14 plus 20 plus 26 plus 32 and so forth all the way till I got 116. Or I can do this. I can go 116 is equal to the, and I could use this formula up here, the 0th term plus d to the n. The 0th term, if I was going to go backwards, 8 minus 6 is 2 minus 6 is -4. This would be -4 plus 6 times n. I'd add 4 to each side. I get 120 equals 6n. Divide by 6, and I get n is 20. So I'm going to put that 20 right there, and I'm just going to go 20 over 2, which I know is 10, but I didn't see that quick enough. 2 plus 116 gives me 1180. Okay, now back up here. I've got this. This I recognize as geometric because it's set up a first term times a ratio to the power of k minus 1. So my first term is 3 times 1 minus the ratio is 1/2 to the power of n, which is 6, all over 1 minus 1/2. And if I type that in my calculator, 3 parentheses 1 minus parentheses 1 over 2, 1/2, all to the power of 6, all over 1 minus 1/2 gives me, oh, shut up. Where did I screw up? Oh, that's where I screwed up. I need another big parenthesis there. Equals 189 over 32, and I'll leave it there. I guess I could change that to 5.90625, but I'll just leave it like that as a fraction. Okay. Identify the common ratio, determine if it converges or diverges, evaluate the sum. So ratio, it's getting smaller, 2793. The ratio you can always find, by taking a term divided by the term before it. 9 over 27 is 1/3. Well, that's smaller than 1, so this is going to converge, because if it's getting smaller, the ratio is smaller than 1, it's going to converge, which means I'm going to use this formula. The first term all over 1 minus the ratio, which 27, 1 minus 1/3 is 2/3. 27 divided by 2/3, that's going to be 40.5 or 81/2. And there it is. This one, I see the ratio is right there. It's the base of the exponential. So the ratio is 3/2. This is going to diverge because the ratio is bigger than 1. And that's it. Cool. Okay, let's look at this. An auditorium has 35 rows. The first row has 20 seats. Second row contains 2 more than the first. So right now, I know that this is an arithmetic because it's increasing by 2 every time, right? Yes. Okay. Now, how many total seats? Well, it's an arithmetic sequence, which means I can take n over 2, which n is the number of rows. That's 35 over 2 times the first row, which is 20, plus the last row, the 35 rows. So I need to figure out how many are in the 35th row. Well, I can use this formula, a sub n equals a sub 0. Well, first row has 20. and it's 2 more. So the zeroth row I have 18, 20 minus 2, right? Plus the difference, which is 2 times n. Yeah, and if I put a 35 in there, 18 plus 2 times 35, oh, that's going to be 88. Means my last row has 88 seats. And if I type that into a calculator, 35 over 2 times 20 plus 88, that gives me 1890. There are 1,890 seats in this auditorium. Okay, now what about this one? A job starts at 28,007 with the yearly increase 2.5% after the first year. The average person retires after 30 years. What's the total lifetime salary? Well, if they get a yearly increase of 2.5%, that means my ratio is 1.025. Remember, if you get an increase or a decrease, you just have to add or subtract 1. So this really is saying use that formula. So I've got my first year, which is 28,700 times 1 plus 1.025 to the power of 30, because we're talking a 30-year career, all over 1 plus 1.025. Okay. 28,700 times 1 plus 1.025 to the power of 30, all over 1 plus 1.025. That gives me, that can't be right. Oh, there's my problem, dummy. I did minus. I did plus in there, didn't I? Did I say plus? No, I said plus. It should be minus. The formula up there says minus. It's going to say 43,000. That doesn't make sense. So minus, and there we go. 7.58. So that's oh no, there's that $1,260,007 and some change over the entire career. Okay, there's the first page. Moving on to the second.